Hi, today I'm gonna talk about the proof of the derivative of x to the n, okay? So if you have the derivative of this function right here, it's kind of got a derivative of x to the n respect to x. This will equal n times x to the n minus 1. What's the proof of that? Okay, so here we go. What is the derivative in the first place? The derivative of a function f of x, okay? The derivative of this function with respect to x is very important. The variable of the differentiation is very important to be explicit, okay? It's gonna be equal to f of x plus delta x minus f of x, all this divided, well, actually it's going to be the limit, right? It's going to be the limit of this thing here as delta x goes to 0. Great. So that's what we're going to do. I'm going to get this thing here. This is not going to work. I'm just going to erase this. I'm going to get this differentiation, drag it over here. Okay, so that's what we're going to do to the function, okay? So you have, it'll be the limit as delta x goes to 0. This is always going to be the limit, okay? Even if I don't say it's going to be the limit as delta x goes to 0, the limit as delta x goes to 0, the limit as delta x goes to 0. Otherwise, it just gets redundant. So you have x, you have x to the n, right? So it's going to be x plus delta x to the n minus x to the n divided by delta x. Now this delta x is in here is just going to be, I'm going to put the limit in here again. Delta x goes to 0. Just going to be a multiplication, right, of 1 divided by delta x. Just going to get it out of here and put it to the side. Now here we're going to have a binomial expansion to the n, and this is kind of complicated. First, you guys have to understand how binomial expansion works, okay? Binomial expansion works, yeah, I'm just gonna put these things on the side here, and then I'll erase them. So if you have x plus delta x to the n, what you're gonna have, let me see. You're gonna have x to the n is going to be the first term to the n, okay? And times the second term to the 0. Why? Because these two coefficients, they have to sum, they have to add and result in n. Okay, so n plus 0 equals n. Plus, you're going to do the first term, and then you're going to subtract 1 unit from its power. It'll be x to the n minus 1 times delta x to the 1, which is just delta x, plus x to the n minus 2 times delta x squared. And it'll just keep going, all the way to x to the 0 times delta x to the n. That's binomial expansion. And there's something else too. You got coefficients in here. Okay, you got a coefficient here. You got a coefficient here. You got a coefficient here. So in each one of these terms, you have a coefficient. Now, what's this coefficient gonna be? The coefficient is gonna be the combination of n with the number that's in here. So in this case, it's just gonna be 0. All right, and the combination, what is this stuff in here? Well, it's gonna be n factorial divided by 0 factorial times n minus 0 factorial. Okay, in this case, it's just going to be n factorial divided by 0 factorial divided by n factorial. So these two cancel out. What do you have? You have 1. So it's already been studied that the first coefficient of a binomial expansion is going to be 1, and the last coefficient is also going to be 1. Now, the second coefficient and the last to second, the second to last coefficient. So you have a second coefficient and you have a second to last coefficient. They're going to be equal to n. Why? Because the second coefficient is going to be a combination of n and 1. Okay, so this is going to be n factorial divided by 1 factorial, which is just 1, divided by n minus 1 factorial. Now, what can you do with this n in here? You can just cut this out and transform this into n times n minus 1 factorial. These two factorial cancel out, and you're just left with n, right? So I'm gonna redo this thing here this way. This binomial expansion here, this one, is going to be equal to x to the n. I don't have to put a delta x to the 0 because delta x to the 0 is just 1. Okay, plus n x to the n minus 1 delta x plus n x. Actually, it's not going to be n. It's going to be another coefficient here, but I don't care what it is. It's just going to be n, a combination of n and 2. X to the n minus 2 delta x squared plus, right? And it'll just keep going. And then you have plus, what is 1. And then you have the x to the 0 and delta x to the n. That's what you're going to have, okay? So this is the binomial expansion. In here, you have minus x to the n. Where is this coming from? It's this one right here. Okay, you can't forget about that. So all this, right, is being multiplied in here. I know it's a mess, but it works. Being multiplied in here by 1 divided by x, which is this one here, right? Now here's what we're going to do. You have, let me put a multiplication here, and like this. What do you have here? You have x to the n minus x to the n, so these two cancel out, okay? And now, you see, you're going to have delta x in every term. You have in this term, you have in this term, you have in all the terms. So since you have delta x in every term, you can divide it now, because you couldn't divide it before. Why you couldn't divide it before? Because how are you going to divide this by this one, okay? When you have a bunch of additions and multiplications here, minus something, plus something, minus something else, and you divide this, for example, by delta x. If you divide this by delta x have to be present in all of these, okay? If this one here, for example, doesn't have delta x, you can't divide. But guess what? When you have a x to the n here and a minus x to the n here, these two x to the n cancel out. So now this x to the n here doesn't exist anymore, so you can divide. Now dividing x to the delta x here in the denominator, you get this delta x out, this delta x, which is squared, is going to be 1, okay? And delta x divided, delta x to the n divided by delta x is just going to be delta x to the n minus 1, okay? Now the limit as delta x goes to 0, guess what? You got a delta x in here, so this whole thing goes to 0. And all the others go to 0 too. And delta x to the n minus 1, so this whole thing goes to 0. What's the only thing that's left out of this whole mess? It's this thing right here, which is what? N times x to the n minus 1. And that's what you had before, right? The derivative of x to the n with respect to x was n times x to the n minus 1. And there you go.